press the bell icon on the YouTube app and never miss another update.
Hello students, today we continue the next problem in increasing and decreasing functions. So the next problem is very important problem. Prove that y is equal to 4 sin theta divided by 2 plus cos theta. Y is equal to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function of theta in 0 to pi by 2. Prove that y is equal to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function of theta in the interval he has given. In the interval 0 to pi by 2 means 0 is also included, pi by 2 is also included. In the interval 0 to pi by 2, what we prove? This function is an increasing function. That means we have to prove that dy by d theta, here it is theta, dy by d theta greater than or equal to 0 in 0 to pi by 2. Understand the concept? Dy by d theta greater than or equal to 0 in the interval what? 0 to pi by 2. So, okay, what we do? We differentiate this function with respect to theta. Carefully you also differentiate. You know very well about the derivative. So, you also differentiate individually. So, differentiate with respect to theta. So, dy by d theta. So, this for quotient rule 2 plus cos theta whole square. Correct na? 2 plus cos theta into derivative of numerator 4 cos theta minus 4 sin theta into derivative of 2 is 0, derivative of cos theta is minus sin theta. This part is over, minus 1. Understand? Minus 1. Denominator square. Denominator into derivative of numerator minus numerator into derivative of denominator. So that is equal to, we simplify this one first. 2 plus cos theta whole square. So 4 we multiply these two terms. 8 cos theta, correct na? Plus 4 cos theta into cos theta what? Cos square theta minus into minus plus 4 sin square theta minus 1. This is the next step. What we do? We take common 4. If I take common 4, it becomes cos square theta plus sin square theta. Cos square theta plus sin square theta is what? 1. So right here, cos square theta plus sin square theta is 1. That is equal to 8 cos theta plus 4. Correct na? Because if I take common 4, cos square theta plus sin square theta is 1 divided by 2 plus cos theta whole square minus 1. 2 plus cos theta whole square minus 1. Take the LCM. LCM is what? 2 plus cos theta whole square. 8 cos theta plus 4 minus 2 plus cos theta whole square. It is in the form of what? A plus b whole square. That is equal to 2 plus cos theta whole square. 8 cos theta plus 4 minus cos square theta. Correct? A square plus b square. A square is what? 2 square. B square is what? Cos square theta minus 4 cos theta. Minus 4 cos theta. So here observe here, plus 4 minus 4 get cancelled. 8 cos theta minus 4 cos theta, what left? 4 cos theta. Correct na? Minus cos square theta divided by 2 plus cos theta, 2 plus cos theta whole square. 2 plus cos theta whole square. So what we do? So we take the common in the numerator is cos theta. If I take common cos theta, 4 minus cos theta divided by 2 plus cos theta whole square. This is what? Dy by d theta. Dy by d theta. Okay. In the interval 0 to pi by 2. See, observe here. If I substitute 0, as 0 is 1, 4 minus 0, it is 3. So this is positive, this is positive, this is positive. If I substitute pi by 2, 0. If I substitute pi by 2, 0, anything is 0. Means d in the interval 0 to pi by 2, cos theta, first quadrant, greater than or equal to 0. This is the first one. Comma 4 minus cos theta, that is also greater than 0. Correct now? So 4 minus cos theta is always greater than 0. And 2 plus cos theta whole square, that is also greater than 0. This is only greater than or equal to 0 because cos pi by 2 is 0. All these things, what? 4 minus cos theta is also greater than 0. 2 plus cos theta whole square is also greater than 0. That implies dy by d theta greater than or equal to 0 for all theta belongs to 0 to pi by 2. For all theta belongs to what? 0 to pi by 2. Then what is the conclusion? Therefore, y is an increasing function for all theta belongs to 0 to pi by 2. Y is an what? Increasing function for all theta belongs to 0 to pi by 2. See this problem. This is also very important problem. Very, very important problem. Observe this problem carefully. So very important problem. Next problem. First you have to observe very carefully for this problem. Next problem. Next problem number 10. Prove that the logarithmic function is strictly increasing on 0 to infinity. Positive real numbers. Prove that the logarithmic function is strictly increasing on 0 to pi by 2. 0 to infinity. That is nothing but the positive side of the real numbers. Okay, very simple problem. log x. We have to differentiate this one. F dash of x. F dash of x is what? 1 by x. No doubt 1 by x is not greater than 0 for each. For each x belongs to 0 is excluded. 1 by x, it is greater than 0. Derivative of log x is what? 1 by x. 1 by x is greater than 0 for each x belongs to 0 to infinity. Hence, very simple question. Hence, f of x is strictly increasing on 0 to infinity. Understand? F of x is what? Strictly increasing on 0 to what? Infinity. Next problem. So, 11th question. Prove that the function f given y f of x is equal to x square minus x plus 1 is neither strictly increasing nor strictly decreasing on minus 1 to plus 1. He has given the interval. In between minus 1 to plus 1, what we have shown that the function is neither increasing nor what? Decreasing. Okay, same procedure. F of x is equal to x square minus x plus 1. F dash of x is what? 2x minus 1. F dash of x is equal to 0. 2x minus 1 is equal to 0. X is equal to 1 by 2, that is clearly 0.5. This is what the critical point. In this point, the tangent is parallel to x-axis. We draw the number line. We take only from minus 1 to plus 1. Only in that here I ask 0.5. 0.5. In this interval we check, and in this interval we have to check. In this interval, so 0 is there, f dash of 0, 2 into 0 minus 1, it is minus 1, less than 0, negative. Correct? Negative. 0.521. 0.521, what we do? We have dash of 0.6 we have to take. 2 into 0.6 minus 1, no doubt, it is greater than 0. The value, it is positive, right? The value, it is greater than 0, positive. So, hence, that implies, right here only, that implies f of x is strictly decreasing on minus 1 to 0.5. Correct now? F of x is strictly decreasing on minus 1 to 0.5, and f of x is strictly increasing on 0.5 to 1. Hence f of x is what? F of x is, so what he has given, neither strictly increasing nor strictly decreasing on minus 1 to plus 1. Correct now? Neither strictly increasing nor strictly decreasing on minus 1 to plus 1. This also same what we discussed in the previous problems, same type problems. Okay now? So see this problem, next problem. Next one. Find the least value of A such that find the least value of A such that the function f given by f of x is equal to x square plus ax plus 1 is strictly increasing on 1 comma 2. F of x is strictly increasing on 1 comma 2. This is very different concept. So at what value of A the function is what? Strictly increasing. Okay. So he has given the interval 1 comma 2. What we do? We differentiate this one. F of x is equal to x square plus ax plus 1. F dash of x is what? 2x plus a. Correct? So since x belongs to 1 comma 2, this is given. X belongs to what? 1 comma 2. So that implies x is greater than 1, less than 2. Correct now? X is what? Greater than 1, less than 2. What I do? I multiply by 2. 2x is greater than 2, less than 4. Correct? 2x is what? Greater than 2, less than 4. Plus a I have to add. 2x plus a greater than 2 plus a less than 4 plus a. So that implies what? F dash of x is greater than 2 plus a less than 4 plus a. Greater than 2 plus a less than 4 plus a means it is that implies 2 plus a is always greater than 0. Correct now? For strictly increasing what? It is greater than 0. A is greater than minus 2. A is greater than minus 2. Hence the least value of A is minus 2. Understand? The least value of A is what? Minus 2. This is for a 2-mark questions. Very simple question. See this problem. Next problem. Next problem. Let I be any interval, I be any interval disjoint from -1 to +1 means exclude from. I be any interval exclude from what? -1 to +1. Full stop. Prove that. The function f given by f of x is equal to x plus 1 by x is strictly increasing on I. See this. First we see the interval of I. That is very important. It is from -infinity. Here it has given -1 +1 plus infinity. What we have to prove that? See this problem. I be any interval disjoint from this one means from -infinity to -1. Here -1 is also excluded because here it is included. And 1 to infinity, 1 is included. This is nothing but the interval of I. This is nothing but what? The interval of I. In this interval, carefully observe. In this interval, what we have to prove that it is a strictly increasing function. Understand? It is a strictly increasing means in the interval -infinity to -1, f dash of x greater than 0, and in the interval 1 to infinity, f dash of x greater than 0. This we have to prove that. Understand? In the interval -infinity to -1 is excluded, and 1 to infinity, what? F dash of x greater than 0. Okay, very simple question. Write down the function. F of x is equal to x plus 1 by x. Differentiate it with respect to x. F dash of x 1 minus 1 by x square. Derivative of x is 1. Derivative of 1 by x is okay. Then f dash of x square minus 1 divided by what? X square. No need to find out the intervals, critical points. Okay, so we have to check only the interval lies from -infinity to -1 and 1 to infinity. For that, what we do in this interval? I take -2. F dash of -2. -2 square is what? 4 minus 1 divided by 4. 3 by 4 greater than 0. Positive. Correct now? 3 by 4 greater than 0. Positive. F dash of 2. That is also 3 by 4 greater than 0. Positive. Correct? We write the conclusion term. So here also positive, here also positive. Then first one. In the interval -infinity to -1, comma, f dash of x greater than 0. Positive. Hence, f of x is strictly increasing function. F of x is what? Strictly increasing function. Second, in the interval, we club this one, no problem. In the interval, what? 1 to infinity, f dash of x greater than 0, positive. Hence f of x is what? Strictly increasing function. Hence proof. Just write simple one sentence. Hence proof. Because what he asked, prove that the function f given by f of x is equal to x plus 1 by x is strictly increasing on I. Yes, it is strictly increasing on I. See this problem? Next problem. Next one, prove that the function f given by f of x is equal to log of sin x is strictly increasing on 0 to pi by 2 and strictly decreasing on pi by 2 to pi. See this question, very important question, very simple question. So prove that the function f given by f of x is equal to a composite function. You know how to solve the composite derivative in the derivative classes. So this is a composite function. First we take f of x is equal to log of sin x. F dash of x. Firstly, we derivative of log x is 1 by x, 1 by sin x. Derivative of sin x is cos x. F dash of x, cos by sin is cot x over cot x. This is for 3 more questions, very simple questions. See this, what he asked? Prove that it is strictly increasing on 0 to pi by 2. 0 to pi by 2 means first quadrant. Pi by 2 to pi means second quadrant. Pi by 2 to pi means second quadrant. In the first quadrant, cot is positive. Cot is positive means f dash of x is positive. F dash of x is positive means it is strictly increasing. Correct na? In the interval pi by 2 to pi, cot is second quadrant. In the second quadrant, cot is negative. Cot is negative means f dash of x is negative. F dash of x is negative means it is what? Strictly decreasing function. That also you have to write. First one over. Problem is over. First one. In first quadrant, that is 0 to pi by 2, comma, cot x is positive. Hence, f dash of x greater than 0, or else that implies, next line we have to write, positive. Hence, f of x is what? Strictly increasing function. F dash of x, is positive. F of x is what? Strictly increasing function. Second one. In second quadrant, that is pi by 2 to pi, cot x is negative. That implies f dash of x less than 0, negative. Hence f of x is what? Strictly decreasing function. F of x is what? Strictly decreasing function. See, observe, this is for 3-mark question. It is very simple question. See, very important question also. What he has proved, the function f given by log of sin x is strictly increasing on first quadrant and strictly decreasing on second quadrant. In the first quadrant, cot is positive, that's why it is strictly increasing. In the second quadrant, cot is negative, that's why it is strictly decreasing function. See this problem. Next problem. Next one, same type problem. Prove that the function f given by f of x is equal to log of cos x. F of x is equal to log of cos x is strictly decreasing on 0 to pi by 2. Strictly decreasing on 0 to pi by 2 and strictly increasing on pi by 2 to pi. Strictly increasing on pi by 2 to pi. Same method what we follow in the previous problem. Okay, so we take the function first. F of x, write here solution. F of x is equal to log of cos x. F dash of x 1 divided by cos x. Derivative of cos x is minus sin x. F dash of x is what? Minus tan x. F dash of x is what? Minus tan x. F dash of x is minus tan x. Okay. First one. In the interval 0 to pi by 2, tan x is positive. That is, tan x is positive in first quadrant. Tan x is positive in first quadrant. That implies, see, observe here, this is positive. Positive into negative, negative. That implies f dash of x less than 0, negative. Hence, f of x is what? Strictly, f of x is what? Strictly decreasing function. Strictly decreasing function. Second one. In the interval, what? Pi by 2 to pi. Tan x is negative. That is, tan x is negative in second quadrant. Tan x is negative in what? Second quadrant. That implies f dash of x. See, observe here, negative into negative what? Positive. Greater than 0. Positive. Hence, f of x is strictly what? increasing function. F of x is what? F of x is what? Strictly increasing function. Same type problem what we discussed in the previous problem. Very important problem. These two problems are very, very important. See this problem. Next problem. Next one. Next problem. Prove that the function given by prove that the function given by f of x is equal to x cube minus 3x square plus 3x minus 100. X cube minus 3x square plus 3x minus 100 is increasing in R. Prove that the function given by f of x is equal to what? X cube minus 3x square plus 3x minus 100 is increasing in R. In R means, so what we have to show that? We have to show that from minus infinity to plus infinity, set of all real numbers, minus infinity to plus infinity, f dash of x greater than or equal to 0, increasing, not strictly increasing, just he asks increasing, f dash of x greater than or equal to 0. From minus infinity to plus infinity, what we have to show that? We have to show that f dash of x, what? Greater than or equal to 0. Correct na? So, okay, you also solve. So, he has given the interval, everything, just only we have to differentiate and we have to show that. Given f of x solution, f of x, x cube minus 3x square plus 3x minus 100. Okay, now what we do? We have to differentiate f dash of x. Differentiation of x cube is what? 3x square minus differentiation of 3x square is what? 6x. Derivative of 3x is what? 3. Derivative of 100 is 0. Correct na? Derivative of 100 is 0. So f dash of x, what we do? We take 3 common. X square minus 2x plus 1. We take 3 common. Then see this function carefully. So thus we can run as x square minus 2x into 1 plus 1 square. Both are same. Why I write this one? A square minus 2ab plus b square, f dash of x, 3 into a minus b, x minus 1 whole square, x minus 1 whole square. This is what? F dash of x. Correct now? Observe carefully. This is what? F dash of x. Due to square, carefully you have to observe, due to square, f dash of x is always positive. Correct now? So if you substitute any value from minus infinity to plus infinity, it is always positive and equal to 0 or equal to 0. That implies what I write? F dash of x greater than or equal to 0 for each x belongs to R. It never negative. It never negative. It is either equal to 0 or greater than 0 for each x belongs to R. Then what is the conclusion? That implies f of, hence right here, that implies अथवा hence f of x is increasing function on R. Increasing function on R. Set of all real number, that is from minus infinity to plus infinity. F of x is an what? Increasing function. See this problem once again. Observe carefully. Next problem. Next question. Which of the following functions are strictly, simple question, very simple question, strictly decreasing? Which of the following functions are strictly decreasing on 0 to pi by 2? He has given 4 functions. I write all the functions. First one, cos x. Second one, cos 2x. Third one, cos 3x. Fourth one, tan x. In the interval 0 to pi by 2, among these 4 functions, which are the functions strictly decreasing? Means what? Derivative is negative. First function, I take first one. F of x is equal to cos x. F of x is equal to what? Cos x. Okay. F dash of x minus sin x. 0 to pi by 2 means what? First quadrant. 0 to pi by 2 is what? First quadrant. F dash of x is what? Minus sin x. Observe here. In the interval 0 to pi by 2 bracket ಒಳಗಡೆ write the first quadrant. Sin x is positive. Correct na? Sin x is positive. That implies f dash of x what? Less than 0. Here is given less than or equal to not, because 0 is excluded, pi by 2 is also excluded. Less than 0 bracket means negative, because positive to negative. Hence f of x is equal to cos x. F of x is equal to what? Cos x is what? Strictly decreasing on 0 to pi by 2. Is what? Strictly decreasing on what? 0 to pi by 2. First question is over. Yes, which of the following functions are strictly decreasing? First one is what? Strictly decreasing. Okay, first one is over. We will take the second problem. I take fourth one. Fourth one I take first. Next problem. F of x is equal to what? Tan x. F of x is equal to what? Tan x. Differentiate with respect to x. F dash of x. Secant square x. Correct now? Secant square x is negative or positive? Positive, because in the first quadrant secant is positive. See, observe here. In the interval 0 to pi by 2 bracket, that is first quadrant secant x is positive. Secant x is positive. That implies f dash of x greater than 0. F dash of x is what? Greater than 0. Hence, f of x is what? Strictly increasing function. So, which of the following functions are strictly decreasing? This is not strictly decreasing function, because it is strictly what? Increasing function. First one is over, second one is over. We will see second and third problem. Sorry, first one is over, fourth one is over. We will see the second and third problem. Second one, f of x is equal to cos 2x. F of x is equal to what? Cos 2x. F dash of x minus 2 sin 2x. Correct now? Derivative of cos ax minus a sin ax. F dash of x is equal minus 2 into sin 2x, you know, 2 sin x into cos x. Correct? Sin 2 theta, first PUC, 2 sin multiple angle, 2 sin theta into cos theta. F dash of x minus 4 sin x into cos x. See, observe here, in the first quadrant, sin is also positive, cos is also positive, positive into negative, negative. So, it is strictly decreasing function. In the interval 0 to pi by 2, that is first quadrant sin x and cos x are positive. Sin x and cos x are positive. That implies f dash of x is less than 0, negative. F dash of x is what? Less than 0, negative. Hence, what? F of x is strictly what? Decreasing. F of x is what? Strictly decreasing function. F of x is what? Strictly decreasing function. Okay, this is also, which of the following is strictly decreasing on 0 to pi by 2? Cos 2x is also strictly decreasing on 0 to pi by 2. First one is correct, second one is correct, fourth one is wrong. What we left? we left only the third problem. Third problem is what? Cos 3x. We will check this one also. Same method. F of x is equal to cos 3x. Differentiate. F dash of x minus 3 sin 3x. Minus 3 sin 3x. Directly we will say that sin 3x is also positive. Or else we write like this. Minus 3 into 3 sin x minus 4 sin cube x. Correct now? 3 sin x minus 4 sin cube x. Correct? See, observe here. Sin is positive. This one is also positive. Correct? So these two quantities are positive means here this one is negative. Positive into negative is what? Negative. Yes. Or else sin 3x is equal to 0. Equal to 0, 3x is equal to 0, x is equal to 0. So you solve any one of the method, any one method you follow. Okay, so what we do? Sin x minus 4 sin cube x. So in the interval, direct, in the interval 0 to pi by 2, that is first quadrant, sin x is positive because sir here it is cubic. Yes, now your doubt is sir here it is cubic, this is more quantity. No, it is less quantity. Why? So 0 to pi by 2, all values, sin 30 degree 1 by 2, sin 45 degree 1 by root 2, sin 60 degree root 3 by 2. See this. All the quantities is decreasing when compared to this value. That's why it is always what? Higher values. So it gives the positive result. It gives the positive. On LCM if you take, it gives the positive result. That's why sin x is positive and this quantity, which one? Sin 3x is positive. If sin 3x is positive, positive into negative is what? Negative. Okay, f dash of x less than 0, that is what? Negative. Hence f of x is strictly what? Decreasing function. F of x is what? Strictly decreasing function. So here, this is one is also true. Among these 4, 1, 2, 3, 4, 3, which of the following functions are strictly decreasing on 0 to pi by 2? These 3 are strictly decreasing on 0 to pi by 2. This one is only strictly increasing on 0 to pi by 2. Understand? So we stop this one. We continue the remaining problems in the next class. Thank you.